For decades, the electric vehicle race ran on one set of rules: bigger battery, faster charge, longer range. Every single manufacturer on the planet was playing the exact same game on the exact same board, fighting over the exact same problem. Then, inside a guarded test facility, that entire rulebook got torn apart, and almost nobody outside those walls even noticed it happening. And if even half of what is now leaking out turns out to be true, this race is already finished before most people even realized it restarted. The name sitting dead center of all of it is Elon Musk. And what he is hiding behind is about to change everything you thought you knew about electric cars. The race. Everyone thought they understood. The story starts in 1996 when General Motors introduced the EV1. Now, this was not some science project locked away in a laboratory. This was a real electric car that real people could lease and drive on real roads, although only in California. California had just passed a law demanding that car makers sell a certain number of zero-emission vehicles, and the EV1 was General Motors' answer to that law. The people who got their hands on one fell in love with it almost instantly. The car was quiet, it was fast off the line, and it ran without burning a single drop of gasoline. So, drivers lined up to lease one. And when their lease neared its end, many of them begged General Motors to let them buy the car outright. They offered to pay full price. They even offered to sign away any right to sue if something ever went wrong with it. General Motors said no every single time. Then General Motors did something that still confuses people today. The company sent trucks out to collect every single EV1 left on the road. Drivers who loved their cars were told the lease was over and the car had to go back, no matter how hard they pleaded. Once General Motors had the cars in hand, the company hauled them out to a testing facility in the Arizona desert and crushed them into blocks of scrap metal, one after another, until almost none were left in existence anywhere. But the owners did not let this go quietly. A group of them even organized a real funeral for their cars. They rented a hearse, brought flowers, and stood together in a Los Angeles cemetery and mourned a machine the way you would mourn a person. Does that sound extreme to you? Maybe it does, until you remember exactly what these people had lost. They had driven a car that worked, a car that produced zero emissions, and a car that General Motors had built, tested, leased out, and then destroyed on purpose. Some people pointed to oil companies that had no interest in a gasoline-free future. Others pointed to General Motors' own parts and service business, which made far more money fixing engines than it ever could maintaining electric motors. General Motors itself never confirmed any of it, and nobody there has ever given a straight answer for why those cars had to die. That single event set the tone for everything that followed. The electric car industry spent the next 2 decades chasing one idea: build a bigger battery, make it charge faster, and stretch the range a little further every year. Tesla proved this could actually work. The Roadster came out in 2008 and showed the world that an electric car could be fast and exciting instead of slow and boring. The Model S followed in 2012 and finally answered the question every driver was afraid to ask: what happens if I run out of charge in the middle of nowhere? By 2020, Volkswagen, Ford, General Motors, Toyota, and Mercedes-Benz had all promised to go fully electric within years. The race looked simple: more battery, more range, more speed. And for 20 years, nobody questioned whether that formula could keep working forever. But that formula was already starting to run out of road. Because the truth is that the battery technology powering every electric car on the road has a hard limit. Scientists can improve how much energy a battery holds, but the rate of improvement has been slowing down for years. The bigger problem is that you cannot engineer your way around basic physics. Lithium-ion chemistry only has so much room to grow, and the industry has been quietly running into that wall for years. Then there is charging. Fast charging sounds great in an advertisement, but here is what actually happens when you fast charge a battery. You are forcing a large amount of energy into the cells in a very short amount of time, and that creates heat. Then that heat starts breaking down the chemistry inside the battery a little more every time, so that 400-mile range you paid for slowly turns into 350, then 300, and you barely notice until the damage is already done. Now, this is not just hypothetical. In 2021, General Motors recalled every single Chevrolet Bolt it had ever sold. more than 140,000 cars, because the batteries kept catching fire. One of those fires destroyed a family's entire house in San Diego, while the car sat charging in the garage. The repair bill for General Motors came to nearly $2 billion. And it was not just General Motors. Hyundai recalled around 90,000 of its Kona electric cars for the exact same battery defect, built by the exact same supplier. Two different car companies, two different brands, and the same battery quietly failing inside both of them. To add to the problem, every battery needs cobalt, nickel, manganese, and several rare earth minerals, and those minerals are not spread evenly around the world. Over 70% of the world's cobalt comes from one country, the Democratic Republic of Congo. Most of the processing for rare earth minerals happens in China. So, the entire electric car revolution, the one that was supposed to free the world from depending on unstable oil-producing countries, ended up depending on a different set of unstable supply chains instead. This was the world the industry had settled into. A battery with a ceiling, a charging system that quietly destroys itself, and a supply chain built on minerals controlled by a handful of countries. Everyone in the business knew it, but nobody wanted to say it out loud because the story was working too well to interrupt it. Then, in 2024, something started leaking out of SpaceX and Tesla that had nothing to do with any of this. According to documents and engineering presentations that reportedly circulated quietly for months, engineers inside both companies had been working on something far beyond a better battery. Most of what the public saw at the time were the normal Tesla updates: a new battery cell, a better cooling system, a faster factory line. All real, all useful, and all beside the point. Because buried inside technical papers and live-streamed presentations watched by a few hundred specialists was something else entirely, something engineers were reportedly calling a replacement, not an improvement. The idea is said to come from SpaceX's Raptor engine, the one that powers the Starship rocket. Raptor runs on something called a full flow stage combustion cycle, an engine designed so efficient that for 50 years almost nobody could actually build one that worked. The Soviets tried in the 1960s and only got part way there. SpaceX did not just build one. They built dozens, tested them, blew a few of them up along the way, and eventually got it running reliably. What reportedly carried over into the car world is not the rocket engine itself. It is the underlying idea behind it, the approach to squeezing every last bit of usable energy out of a system instead of wasting it as heat. Applied to an electric motor, this approach is said to recover energy that would normally be lost at every stage of power delivery instead of just one. According to people who have reportedly reviewed early internal testing, the real-world efficiency gain sits somewhere between 30 and 40% over the best electric motors currently on the road. 30 to 40% does not sound like a headline. But hold on, because once you understand what that number actually means, you will understand why some people are calling it the biggest shift in this industry since the battery itself. What the number actually means, and why the silence is louder than the claim. A 30 to 40% efficiency gain does not mean cars suddenly drive faster. It means the same amount of stored energy does more actual work. But here is why that matters so much. If you keep the driving range the same, you now need around 30% less battery to get there. Less battery means a lighter car. A lighter car is cheaper to build. And a car that needs 30% fewer battery cells needs 30% less cobalt, lithium, nickel, and manganese, the exact minerals the world has been fighting over for the last decade. So, you do not solve a supply chain problem by negotiating harder with all the warlords in the Congo. You solve it by simply needing less of what they dig out of the ground. There is another piece of this that most people never think about, and it is called the mass spiral. A typical electric car battery pack weighs somewhere between 400 and 900 kilograms. That weight has to be carried around everywhere the car goes, and carrying it takes energy. So you add more battery to get more range, and that extra battery adds more weight, which then eats into the range you just added. Engineers have been fighting this exact trap since the first electric car rolled off a production line. But a 30 to 40% efficiency jump breaks that trap completely. Fewer cells means a lighter pack. A lighter pack needs less energy to move, and that means you can shrink the pack even further. Instead of one problem feeding the next problem, you get one improvement feeding the next improvement. And according to the people who reportedly built it, this is not even the finished version of the technology yet. Now, before you get too excited, just remember that promises like this have come crashing down before. The United States government once handed $249 million to a battery company called A123 Systems, fully convinced it had the next big breakthrough. A123 went bankrupt within 2 years and was sold off to a buyer in China for almost nothing. Henrik Fisker made the exact same kind of promise, not once, but twice. His first electric car company burned through $1.4 billion, including hundreds of millions in government loans, before collapsing in 2014. His second company, Fisker Inc., went bankrupt again in 2024. Even Boeing got burned by a battery breakthrough. The lithium-ion batteries on its 787 Dreamliner passed every single test in the lab. Then, in 2013, they started catching fire in the air, and the entire global fleet had to be grounded for months. Good science in a lab does not always survive contact with the real world, and that history alone is reason enough to stay skeptical here. But is anyone actually skeptical? Strangely, almost nobody is saying anything at all. Now, go back to 2020, when Tesla unveiled its new 4680 battery cell and a new structural battery pack design. Within weeks, rival engineers were publicly tearing it apart, pointing out flaws, comparing notes, and arguing in interviews. That is what normally happens when a major company claims a breakthrough. The industry knows what to look for, and it says so, loudly. But this time, the reaction has been almost nothing. Several of the most respected names in electric motor design have published nothing at all. One senior engineer at a major European car company, speaking only on condition that his name was withheld, said the technology required more study before any real evaluation was possible. Think about what that actually means. Experts do not say a claim needs more study when they believe it is wrong. They say it is wrong, and they explain why. Saying it needs more study is what you say when you genuinely do not know yet, and that uncertainty is far scarier than a confident denial would be. According to private conversations reportedly shared inside engineering circles, the small group of academics who have actually looked closely at the documents believe the underlying theory holds up, with the real doubt sitting on whether it can be built at scale and whether it will hold up over years of real use. And then there is the silence from the companies who should have the most to say. Volkswagen has issued no rebuttal. Toyota, which has poured years into hydrogen fuel cells as an alternative to batteries, has said nothing, even though this would be the perfect moment to attack pure electric technology. General Motors, sitting on billions of dollars invested in its own battery platform, has made no comment. Ford, already losing money on its electric vehicles, has not addressed it either. When companies this large stay this quiet about something this big, there are usually only two explanations. Either they looked at it and decided it does not matter, or they looked at it and got scared. The behavior here does not look like the first explanation. History gives us good reason to take silence seriously. Volkswagen spent weeks in 2015 giving regulators careful, vague answers before finally admitting it had installed software to cheat emissions tests in 11 million cars. Investors and lab experts gave Theranos cautious hedge comments for years before Elizabeth Holmes was convicted of fraud in 2022. Boeing and federal regulators gave careful technical statements for months after two separate plane crashes killed 346 people before the entire 737 MAX fleet was finally grounded. In every one of those cases, the careful, quiet language was not a reassurance. It was a warning sign that nobody wanted to read out loud. So, if the silence really does mean what it looks like it means, the next question is brutal and simple. Who actually loses if this turns out to be real? Who loses if this is real, and why nobody ever sees it coming? Let us rank exactly who gets hurt if even half of this turns out to be true, starting with the company that probably handles it best. Traditional car makers are exposed, but they are not the most exposed. Most of them already have research teams quietly working on what comes after lithium-ion, so while switching would be painful and expensive, they at least have a path forward. Lithium mining companies are in a far worse position. Through the 2010s and into the 2020s, massive amounts of money poured into lithium mining operations across Australia, Chile, Argentina, and Nevada, all based on one assumption: that demand for batteries would keep climbing forever. A motor that needs 30% fewer battery cells does not just slow that growth down. It could turn the whole curve around and send demand falling instead of rising. And that is the gentler half of the problem. Mining lithium takes enormous amounts of water, and in Chile's Atacama salt flats, indigenous communities have spent years fighting lithium operations they say are draining the little water their land has left. Imagine spending years fighting a mining company over your own water supply, only to find out the demand driving that fight might collapse anyway. Cobalt is worse still. It has always been the part of the electric car story nobody wanted to talk about too loudly. The metal is expensive, hard to get, and concentrated almost entirely in one politically unstable country called the Democratic Republic of the Congo. In 2019, families of children who were killed or seriously injured while mining cobalt in the Democratic Republic of Congo sued Tesla directly, along with Apple, Google, Microsoft, and Dell, accusing all 5 companies of profiting from forced child labor. Courts threw the case out in 2024 on a legal technicality, not because the deaths and injuries were not real. They were horrifically real. So a technology that takes a real step toward replacing cobalt batteries altogether does not just shrink that industry, it threatens to wipe it out completely. Then there is oil, sitting quietly at the back of the room and watching all of this unfold. The oil industry has been planning for an electric future for years, just on a slow, comfortable timeline they could manage. A technology that compresses that timeline by an entire decade is not the future they planned for, and oil companies are not exactly known for adapting gracefully under pressure. They have hidden uncomfortable truths before. In the 1970s and 80s, Exxon's own scientists privately modeled global warming with startling accuracy, while the company spent millions publicly funding doubt about the very science its own researchers had already confirmed. Now, here's the part that should really worry you. None of this is actually new. The same pattern keeps repeating itself, and almost nobody ever sees it coming until it is too late to do anything about it. In 2016, the accepted wisdom across the entire aerospace industry was that landing and reusing an orbital rocket was at least a decade away from being practical. SpaceX landed one on a floating platform in the ocean that same year. In 2019, battery researchers were confidently saying solid-state batteries were the real next step, and that they were still 5 to 7 years from being ready for the public. Years later, that conversation is still going on. While a completely different technology, nobody was paying attention to quietly produce bigger gains than solid-state batteries ever promised. Tesla itself tells the same story. The company was founded in 2003, at a time when the accepted wisdom in the auto industry was that there was no real market for an expensive electric sports car. Tesla built one anyway, and it had a waiting list before the car even existed. So, why does this keep happening? It is not because Elon Musk has some kind of special insight nobody else has. It is about incentives. If you have spent 20 years building a career around lithium-ion battery chemistry, your entire professional reputation depends on lithium-ion continuing to matter. Admitting that a new architecture might replace your life's work is not easy, and most institutions do not reward that kind of honesty. The people who usually spot a disruption coming are rarely the senior experts at the big companies. They are the ones with the least to lose and the most to gain from being right. That is exactly how Kodak lost everything. One of its own engineers built the first digital camera back in 1975, but Kodak's leadership buried the project, terrified it would hurt their film sales. Kodak filed for bankruptcy in 2012. Blockbuster did something just as foolish. In the year 2000, Netflix's own CEO offered to partner with Blockbuster for $50 million. Blockbuster did not even take the offer seriously enough to negotiate. Blockbuster does not exist anymore. BlackBerry made the same mistake when the first iPhone came out in 2007. Their own executives were convinced a phone without a physical keyboard and with weak battery life could never threaten their business customers. SpaceX's entire culture, whatever you personally think of the man who runs it, is built around a different way of thinking. Instead of asking what has worked before, they ask what the laws of physics actually allow. Apply that mindset to an electric motor, and you end up with answers. The rest of the motor industry was never even asking the right questions to find, so if the pattern really is repeating itself one more time, the only question left is how fast it moves, and who has already run out of time to catch up. The reckoning timeline. There are two ways this could play out from here, and the gap between them is enormous. The cautious version goes like this. The technology turns out to be much harder to build at scale than the early prototypes suggested. The 30 to 40% efficiency gain is real in a careful lab setting, but a chunk of it gets lost once the messy reality of mass production, supply chains, and manufacturing tolerances gets involved. Even in this version, the impact is still huge. Lighter, cheaper electric cars would open up markets where the cost of a battery has always made an electric car impossible to afford. A slower version of this story is still a massive deal. The aggressive version is the one that should genuinely worry every car company on Earth. In this version, the manufacturing problems get solved, the efficiency gains hold up, and even improve the same way Raptors did with every new version. And the first cars using this motor reach regular buyers within 2 to 3 years. If that happens, every major car company is suddenly working against a brutally short clock. Retooling an entire car factory and supply chain is a 5 to 8 year project at minimum, even if a company moves with the full urgency starting today. Now, before we get to who loses money, think about what this means if you are simply someone thinking about buying a car right now. Do you buy the electric car sitting on the lot today, knowing a cheaper and lighter version might arrive in 2 or 3 years? Or do you wait and risk holding on to a gas car for years longer than you planned? Car companies are asking themselves a version of this same question right now, except their version comes with billions of dollars attached and a factory full of workers waiting on the answer. What does any of this actually mean for a regular person beyond that choice? It does not come down to a government subsidy or a company's marketing promise. It comes down to whether the basic physics behind the car actually got better. And there are already early signs of what that kind of shift can do. In countries like Kenya and India, cheap electric motorcycles and three-wheelers sold through small monthly payment plans have already put electric vehicles into the hands of delivery drivers and everyday commuters who could never have dreamed of affording a car. That is what happens when a battery gets cheaper. It does not just lower a price tag, it opens the door to people who were locked out of the conversation completely. Now imagine that same effect, but with a battery that costs 30% less to begin with. The companies on the losing end of this know exactly what is coming, and the money already proves it. In 2020, oil giant BP wrote off $17.5 billion worth of its own oil and gas assets, openly admitting the shift to clean energy was happening faster than expected. Shell took a similarly massive hit around the same time. Companies do not write off billions of dollars on a hunch. They do it when their own internal numbers leave them no other choice. And it is not just oil companies feeling the pressure. Ford lost more than $5 billion on its electric vehicle division in 2023 alone. And that is with the slow, gentle version of this transition already in motion. To put that into perspective, Ford has been losing that kind of money while competing against batteries that have not even gotten dramatically better yet. So imagine what a faster, more brutal version of this transition would do to a company already bleeding money at that pace. Here is what all of this really comes down to. The story everyone has been told about electric cars was a calm, manageable one. Better batteries, slightly faster charging, steady progress every single year, with no major surprises along the way. That story was comfortable, but it left out the cracks underneath it the entire time. The cobalt mines, the dying water supplies, the lithium-ion ceiling the industry knew was coming. It left out the fact that the most disruptive idea in this entire industry in decades reportedly did not come from inside a car company at all. It came from a rocket program with no reason to protect anyone's old way of doing things. The electric car race that everyone thought they understood is over. Not because electric cars failed, but because the rules underneath them may have just changed completely. The engineers who reportedly understand what is happening are not talking about it loudly yet. The car companies whose entire business depends on the old rules are not volunteering any information either. The press keeps covering the small story, the new paint colors, and the updated dashboards, while missing the much bigger one sitting right next to it. But the documents exist, the test results exist, and somewhere in a facility most people have never heard of, the answer to where this entire industry is actually headed is already sitting on a desk, waiting for someone with enough courage to finally take it seriously.